Hello everyone. Today we will see the molecular point group. How do molecules grouped? Molecules are actually classified in terms of symmetry elements, but symmetry operations present in a molecule form a group. What is symmetry element? It is an imaginary axis or a line or a point about which the molecule is rotated, reflected or taking inversion. So all symmetry operations intersect at a common point and such groups are called point groups. So when we perform any symmetry operations in a molecule, at least any one point must be stationary. In order to predict the point group of the molecule, it is very important to know the structure of the molecule according to VSEPR theory. Now see categories of point group. So the point group is indicated as Cornfly's notation. The molecules with very low symmetry are represented as C1, Cs and Ci. And molecules with intermediate symmetry are represented as Cn, Cnv and Cnh. With high symmetry, they have Dn, Dnh or Dnd, and they have higher order rotational axis. They have icosahedron, octahedron or tetrahedron. The first type, non-axial point groups, called C1 point group. Molecule belonging to this point group has only identity element. We all know that identity element is the molecule is rotated about 360 degree called one-fold axis called C1 point group. So completely asymmetric molecule like this example CHFClBr. So around the carbon all the four functional groups are different and we need to rotate the molecule about 360 degree and hence the point group is C1. So all kind of asymmetric molecules have C1 point group. And the next one, CS point group. Molecules have the reflection plane and identity. So along with identity, if we could find the reflection plane in a molecule, then it has CS point group. So two examples are given. One is formyl chloride and here we could not find any symmetry like a rotation or a reflection, but the reflection about the plane of the molecule is sigma plane. And in this case, the plane passing through bromine and chlorine and these two hydrogens are getting exchanged or interchanged and this one is a sigma plane, hence the point group is CS point group. And third one, Ci point group, and the molecule contains center of inversion and identity element have Ci point group. So one of the examples, 1,2-dichloro, 1,2-difluoroethane, that is in a staggered conformation, and here we can find a point at the center of the molecule and we can find the two opposite corners. There are two hydrogens and the two fluorines and there is an inversion point at the center and we can find the same type of the atom at the opposite corner. So hence it has Ci point group. And second type of the point group, here the molecule has some symmetry. So they are having cyclic type of the point group called C. The first one is a Cn point group. So they have Cn axis alone. Along with identity, they have Cn axis of rotation alone. So this one is one of the example, cis cobalt diene dichloro complex. So here when we rotate the molecule about this axis and these two ene groups are going to be exchanged and these two chlorines are exchanged by rotating this molecule by 180 degree, hence the axis is C2, right? So here the point group is C2 and in this case triphenyl phosphine and the axis passing through the center of the phosphorus and we rotate the molecule thrice called 120 degree and the point group is C3. No other symmetry operations are present in this molecule. And the next type, CNV point group. So the molecule that contains Cn and n number of vertical planes called sigma V planes. So sigma V is nothing but the plane passing through the CN axis. For example, when we take this molecule, the axis passing through this first carbon and the nitrogen is the C2 axis. Because while rotating this molecule through this axis, these 2 and the 5th hydrogen, 3rd and the 4th hydrogen are going to be interchanged. So this is C2 axis, and when we place a plane along this axis, there is a vertical plane, and we can find the same 2 hydrogens are on the other end. So the point group is C2V. And ammonia molecule. So ammonia molecule has a pyramidal geometry. So it has C3V point group. And a tetragonal pyramidal geometry has C4V point group. And this one has C5V point group. And CNH point group. The molecule contains CN axis and a plane sigma H called a horizontal plane, which is perpendicular to the CN axis. So this is a perpendicular plane. So let us take hydrogen peroxide as an example. So here the axis passing through the center of both the oxygen atoms, center of the bond, and while we rotating this molecule 180 degree, and we get the same orientation. So here C2 axis of rotation is there, and along with it the sigma H plane. So that is a perpendicular plane called sigma H. Hence the point group is C2H. Hydrazine. Here also the geometry resembles with the trans hydrogen peroxide. So it also has C2H point group. And boric acid. So it has C3H point group. So the axis passing through the boron, and while we rotating it by 120 degree, we get the same orientation. So C3H point group. And here dichloroethylene. So here the axis passes through the double bond is a C2 axis, and the plane of the molecule is a sigma H plane. And this is not actually the C2 axis, right? And the next type of the point group, very high symmetry molecules have dihedral point groups. So the first type is DN point group. So the molecule has CN axis and N number of C2 axis perpendicular to CN. Okay, so CN along with it N number of C2 axis perpendicular to the CN axis have DN type of the point group. So one of the examples is given, twisted biphenyl. So it has D2 point group. So this one is a C2 axis, and along with it the perpendicular C2 axis is also there. So hence it is called D2 axis. And DNH point group. So the molecule belongs to CN axis and N number of C2 axis perpendicular to CN axis and also sigma H. So if N is even, N is the order. If N is even, then its combination with sigma H generates I. Center of inversion is also there. For example, when we take D2H, so N is even, so we have C2 axis, more number of C2 axis are there in a molecule like ethylene. So the bond axis is a C2 axis and the perpendicular C2 axis, and another one passing through the center of the double bond. So there are more number of C2 axis is there, and it also contains sigma V and sigma H, right? So we have the center of inversion, and if N is odd, then no center of inversion is there. And another one example, benzene. So here C6 axis is passing through the center of the benzyl ring, and more number of C2 operations are there which are passing through the center of the bonds and passing through the first and the fourth carbon, second and the fifth carbon, third and the sixth carbon. So like that. So there are more number of perpendicular C2 axes are there. So hence it has D6 point group and DND type of point group. So the molecule contains CN axis, N number of C2 axis perpendicular to CN, and along with that sigma D plane. So how do we find the sigma D plane? So sigma D is actually a dihedral plane that bisects the angles made by perpendicular axis. So when we find more number of C2 axes which are perpendicular with each other, and if the plane bisects the two C2 axes, for example, when we take a staggered ethane, so this is a C3 axis actually, but the C2 axis, perpendicular C2 axis is this one, and this is also the C2 axis. So if the plane which bisects, right? So if the plane bisects two C2 axes, then this plane is the dihedral plane. So hence this molecule has D3D point group, and similarly for allene, D2D. And the last type is the linear molecules. If the molecule is linear, then there are two types of the point group it may have. One is D infinity H, another is C infinity V. So D infinity H means the molecule is homonuclear diatomic molecules like hydrogen or oxygen, and CO2 molecule like a linear molecule, CO2, like that. So if the molecule is linear, what are the symmetry operations are possible? So the first one is the bond axis called C infinity. So infinite times we can rotate the molecule, we get the same orientation. So this is called C infinity, and infinite number of C2 axis. So this one is C2 axis, right? So there are more number of C2 axis are there, and hence they have sigma H plane. So identity C infinity, infinite number of perpendicular C2 axis and a sigma H operations, then it is called D infinity H point group, and C infinity V. And this point group is there for a heteronuclear diatomic molecules like HCl or CO, like that. So here the bond axis is a C infinity axis and there is no C2 axis perpendicular to that, right? So hence identity C infinity and infinite number of sigma V operations. So C infinity V is a point group. And here this flowchart helps you to predict the point group of the molecule. So you just go along with the way. First you start with the molecule if it is a linear, right? So answer the questions and you go along with this way, and then we can easily find out the point group of molecule. If the molecule is linear, if says yes, if it is linear, then find the molecule has center of inversion, right? So which molecule contains center of inversion if the molecule is linear? Only for homonuclear diatomic molecules, right? So if the molecule contains center of inversion, then the point group is D infinity H. And if there is no center of inversion, the point group is C infinity V. And the next case, if it is of high symmetry, if yes, then find whether center of inversion is there or not. If says yes, then again find CS. If says yes, icosahedron. If it is no, octahedron. If there is no center of inversion, then tetrahedron. And if it is not of high symmetry, if it contains some number of rotation axis, CN axis, right? And if it is yes, then find if there are more number of n number of perpendicular C2 axis are there or not. If yes, then find sigma H is present. And if sigma H is present, definitely the point group belongs to dihedral point group, right? So along with Cn, if n perpendicular C2 axis, then sigma H, then definitely dihedral point group. If there is no sigma H, then there are another cyclic group. So if sigma H is present, DNH. If sigma D is present, DND. If no sigma D, then DN, right? So several examples are given here. Ethylene, ethane. And if there is no perpendicular C2 axis, then cyclic type of the point group. Then sigma H is present, CNH, hydrazine. And if sigma V is present, triphenyl phosphine, that we already discussed, CN. And if there is no sigma V, then if there is no sigma V CN, if there is a sigma V CNV, like water. And if it is of low symmetry, then find sigma is there, plane is there or not. If it is yes, CS, right, formyl chloride. And if it is no, center of inversion, then C1. And if it is center of inversion present, then Ci, right? So this flowchart will help you to find out the point group of any type of the molecule. Thank you.